So what I picked out here is a very difficult A-star level question on A-level mechanics. This is year 2 mechanics, which deals with projectiles and forces as well. So it tells you there's a particle of mass 2 kg, and so that has to be of some use later on in the question, otherwise it wouldn't mention it. It's going across a smooth surface, meaning that when it goes across the surface from point P to point A, friction won't act. The sloping face is 10 meters long, so this length here is 10 meters, and it's inclined at an angle of 30 degrees, okay? It's fired up the slope from its low point P, okay, and with an initial speed of 20 meters per second. It then says after P has reached the point A, which is this point here, it has a speed of 10 root 3 meters per second, and asks you to find the total horizontal distance traveled from P to O. So that means from this position here, all the way as it goes up, back to when it reaches the ground. So how do we do that? Let's play this up into two parts. We first want to find the horizontal distance traveled from point P to point A. Let's call that x1. And then we also want to find the horizontal distance traveled from point A back to the ground. Let's call that x2. x1 can be found using SOHCAHTOA because we have this length here. We know that this is a right angle triangle, and so we can use the relevant part of SOHCAHTOA to find that length x1. So let's do that first in a different color. Using the fact that opposite the angle is this length, the hypotenuse is this length, which is 10 meters, and this is the adjacent. Using adjacent and hypotenuse, we can say cos of the angle 30 is equal to the adjacent of x1 divided by the hypotenuse of 10. Multiply both sides by 10 and we get that the x1 is equal to 10 cos 30, which in your calculator will just give you a value of 15. Sorry, not 15, 5 root 3 meters. So we found the distance traveled from point O to point A in the horizontal direction. Now we need to do the difficult part of the question, in my opinion, which is find the horizontal distance from where it's projected up to when it reaches the ground again. Now, why is this a 13-mark question? Well, before we get started with everything, there's quite a few components to this. So we know that horizontally in air, so let's write this out. Horizontally, we can assume that the acceleration is 0 in air. Now, why is that important? Well, I'm sure you guys have seen the equation s equals ut plus a half at squared. And if acceleration is 0 horizontally in air, we can say that half at squared itself is just all equal to 0. So s equals ut, distance equals speed times time. We're able to say that horizontally, the horizontal distance that's traveled from point A to the ground again, which we want to find, that's x2 by the way, because remember we introduced it as x2 earlier. So let's call it x2 here just for it to be consistent, is equal to the horizontal velocity that it has at the point that it's projected, which we need to find. How do we find that? Well, once again, the fact that it was moving up this slope the whole time, and when it was projected, that means that this angle here is also 30 degrees. They match. So once again, we can use this right angle triangle, use this initial speed of 10 root 3, and use SOHCAHTOA to find the horizontal component of the initial speed. And that's the horizontal velocity that we take throughout the whole journey from point P to back to the ground. So let's do that. I'm just going to draw this right angle triangle out a little bit larger. So there's a speed of 10 root 3 meters per second. It's at an angle of 30 degrees. One thing I wanted to mention, by the way, which is why I paused for a second, be careful with the changes between distances and speeds. It's a little bit confusing. To find that horizontal initial velocity, let's call that A, or let's call it V because that stands for speed, and then H, VH for horizontal velocity. Well, again, we're not using the opposite, we are using the adjacent and we are using the hypotenuse, so we use cos, and we say cos of the angle 30 is equal to the adjacent that we want to find divided by the hypotenuse of 10 root 3. You then multiply both sides by 10 root 3 and you get that the horizontal component of the velocity is 10 root 3 cos 30. 10 root 3 cos 30 degrees, which is then equal to 5 root 3. Yeah, 5 root 3. That's not, sorry. I'm just going to double check. I don't want to teach you guys the wrong thing. It's equal to 15. Sorry about that. 15 meters per second. So that's our horizontal velocity. And then we just want to multiply that by the time taken from when it's at point P for it to go all the way up and then back down to the ground. And that's where we're a little bit stuck. We don't know how to find that. And that's what tells you that because we're dealing with projectiles from point P onwards, we have to also think about the vertical part of the motion of this projectile. So let's do that again in a different color. I like to change colors a lot just because to separate up the work. Is there any way I can change the thickness? Yeah. Okay, looking at the vertical direction now. So displacement is how far you've traveled from where you started to where you finished. If we start at point P and if we end here, the displacement that we've traveled is this distance here. But also bear in mind that because we're taking upwards as a positive distance, we have to take downwards motion as a negative displacement. So let's first find this distance here. That's where we have to go back to this right angle triangle. So as you see, there's so many steps involved, which is why this is an A-star level question. Using the fact again that this is 10 meters long and that this angle is 30 degrees, we can use SOHCAHTOA to find the opposite this time. So what involves the opposite and the height? Well, it's sine. We can say sine of the angle 30 is equal to the opposite, which we're trying to find, all divided by the hypotenuse of 10, multiply both sides by 10, and we get that the opposite is actually 10 sine 30. I did do the working out before, but there's just so many numbers, so I'm getting a little mixed up with the numbers. 10 sine 30 is 5. If this distance here is 5 meters, then the overall displacement traveled in the vertical direction from point P back to the ground is minus 5 meters. Perfect. Do we have the initial vertical velocity? Well, we have the velocity at this angle here, 10 root 3, but to find the initial vertical velocity, we need to once again use SOHCAHTOA to find the vertical component of that velocity once it's projected. I'm just gonna, I've shown you guys like 2-3 times how to use SOHCAHTOA to do that. So I'm just gonna tell you that that component is 10 root 3 sine 30. So 10 root 3 sine 30. Now, when you put that in a calculator, that will get you a value of 5 root 3. So that's the initial velocity in the vertical direction. Now, a question I get asked a lot is, well, this is going upwards and then downwards. Do I first take acceleration as minus 9.81 and then 9.81? Actually, you always take acceleration from the start of the motion. Here, our motion is starting from where it's going upwards, where it's going against gravity, so we take it as minus 9.81 meters per second squared. Sorry, I got cold. And we want to find the time taken for the whole journey. Because once we have that time taken for the whole journey, by the time it's projected, we can multiply on that by the horizontal speed to get the horizontal distance traveled. Hopefully you're seeing how this all ties in together now. One rule with Suvat, by the way, you should always have 3 known variables and 1 unknown variable, which in this case we do. We have S, U, A, but we don't have T. What equation links all of them? Well, it's S equals UT plus half AT squared. So let's put into that equation. S, which is minus 5, is equal to U, which is 5 root 3, multiplied by T. I'm going to multiply the T here, plus a half of A. A half of minus 9.81 is minus 4.905. So let's change that to minus 4.905 T squared. Great. We now take all the terms to one side, and then you can use the quadratic formula to find the value of T. So let's do that. Let's add 4.905 T squared to both sides. Take away 5t root 3 from both sides. And then the minus 5, we can just leave it as it is on the left-hand side and make the right side equal 0. In this case, we can use the quadratic formula with a being equal to 4.905, b being equal to minus 5 root 3, because remember b is the coefficient of the t term, and then c is equal to minus 5. Putting that into the quadratic formula, which I'll just quickly write down here, is 4ac all over 2a. You get 2 values of t. When you use the negative part of the formula, you get minus 0.458. Now straight off the bat, that doesn't really make sense because you can't have a negative time taken for the whole journey. The alternative value of time that you get is 2.22. That makes sense. That means that it takes 2.22 seconds vertically to go from point P back to the ground. Now the vertical time taken for the whole journey is the same as the horizontal time taken for the whole journey. That means that this time taken is also 2.22. And now we can find the horizontal distance traveled from point P back to the ground by doing 15 times 0.22. And that's equal to 33.36 meters. As your final step, you want to add the initial horizontal distance that you got of 5 root 3 onto this extra horizontal distance traveled from point P back to the ground, which is 33.36. Put all of that into your calculator and you get a value of 42 meters to two significant figures. A very difficult question, but hopefully it all made sense. And if you have any questions about it, just let me know in the comments. Otherwise, thanks for watching and have a great rest of your day.